class, welcome to the last video you'll need to watch to prepare for the final exam, which will take place a week from today. I'm filming this on Monday. There are 36 questions. The questions on the final exam itself match the questions on the review in style. So the only thing that will change will be the number values, but you know that like number 1 will be similar to number 1 and so on and so forth. So I've got my laptop here. Number 1 says find the domain and range. And if you just look, all of the whole function, all of the action, so to speak, is happening in that first quadrant. And so it looks like this is going, as this goes up, it's approaching the y-axis, and so it's going from 0 all the way out to infinity. And same with the range, it's going from, as this goes closer and closer and closer to our x-axis, it too is going to approach 0, but it's going all the way up. And so our correct answer is that the domain is greater than 0, the range is greater than 0. And then if we go and do that vertical line test, and we just kind of run our writing utensil held vertically along that function, it only touches one place at a time. And so our correct answer is B. Yes, it is a function. Number 2, I wasn't necessarily able to order the final in the same order in which we learned things. So you might jump from a chapter 7 question like number 1 to question 2. You kind of looked at it in both a little bit of chapter 12 as well as chapter maybe 5 when we talked about function values. So we've got f of x as 4x minus 2. And we've got g of x as negative 2x plus 1. And it asks us to find, we're going to plug in negative 2 into f of x, and we're going to plug in 0 or substitute 0 in for x for g of x, and then we're going to write that, oops, my bad. And then we're going to write that as a fraction. So if I plug in negative 2 here, I get 4 times negative 2, which is negative 8. Take away 2 more, so I have negative 10 in the numerator. In the denominator, if I substitute in a 0, of course, anything times 0 is 0, plus 1. So my final answer is negative 10, which makes the correct answer, once again, B. Oh, I should also mention, I haven't looked at how the answers shake out on the actual final exam. It's not the same one I've used from different years. I modified it a little bit. For this semester, I have no idea if the same answer comes up like A, and then you start maybe to lose confidence or feel like you're doing something wrong. So if you get, it's completely random. Every question is completely independent. If there's any kind of pattern that emerges, just ignore it to the best of your ability. Don't let that throw you off. All right, number 3. Number 3 is from chapter 11. It is the one word problem we looked at from chapter 11. It looks like it's a max or a min problem. So we're looking for where that vertex is of that quadratic function. And so because this is negative, if I just wanted to sketch the graph, we know it's going to open down. So this is going to be a max value. And in order to find that vertex, we're going to use the shortcut formula. X is negative b over 2a. And then the y value or the p value is whatever we get when we actually substitute that value in for x. So if this is positive 10, we're going to do negative 10 over 2 times minus 5. It looks like that gives us negative 10 over negative 10. So that answer is 1. If I plug 1 back into my function, one squared is 1, so this is going to be negative 5. plus 10 times 1 is 10, plus 8. And so 18 take away 5 is 13. We have to check the units to make sure what kind of units we're talking about. It says X is the number of units produced per week in thousands. Since X is 1, then that represents 1,000 units. And 13Y represents, where does it say? Hundreds of dollars. So 13 times 100 is a profit of $1,300, which makes the correct answer A. And I think I included the answers to the review also with the document itself. It should be uploaded to Canvas. Let me know if you don't see it. All right, number 4. You can tell it's also a quadratic, which makes it from chapter 11. It already is in that vertex form. So this is question 4 in case you're trying to scroll through and watch certain questions individually. Let me make sure I wrote that down correctly. Okay, so it's always opposite same. So the vertex here will be at +2, +4. We should look for something that opens down. Is that enough to pick out the right answer in a multiple choice test? Yes, it is. It looks like the correct, if you look at your options, it looks like the correct answer is A, because it's the only one that has the vertex right there and then is going down from there. So no more effort is needed once you've identified that. So the correct answer here is A. 5 is the one where you have to switch it from, it's given to us in standard form. You will need to complete the square in order to put that in vertex form. This is from section 11.7. If you want to go back and review any of those problems, 2x squared minus 16x plus 35. So the first thing we're going to do is we're going to pull a 2 out of the first 2 terms. I'm going to put my blank spot right there. That's where I'm going to complete the square. And then I'm going to add that 35 in the back. And I'm also going to put a blank part in the back. And recall that these have to be opposites. But you are going to need to make sure that you multiply that number by 2 when you go to do the opposite number right here. So we take that -8, divide by 2, we get -4. We square it, and we get a +16. So we're going to put a +16 right there. 2 times 16 is 32. So I'm going to put a -32 in the back so that that remains balanced. Let's rewrite this part. This factors 2 numbers that multiply to a +16 that add up to a -8 is x minus -4. This number is always that number. And then a +35 and a -32 is +3. So my vertex opposite same, 4, 3, which makes the, oh, I don't even need to identify that. This makes the correct answer C. So there you go. I'll probably put these in 2 different parts just to make sure everything is clear. So I'll stop about halfway through probably. All right, number 6, factor the expression 5x squared. Once again, I have sat down without a calculator. Plus 56. So I would use, well, you can either guess and check. So you can just take the 4 answers and FOIL them and figure out which one matches that. It's a multiple choice, and I'm not looking at your work. So people that don't really like that slip and slide method of factoring, that is an option. or I would slip and slide. So we need to multiply 5 times 56, which seems like quite a large number. Let's see how I do here. So that's going to be 280. So I have x squared plus 47x plus 280. And so I need to factor 280 and find factors that multiply to 47. Lucky for me, I actually see them right away. So x plus 40 and x plus 7. If I multiply by 5 in the beginning, I have to go back and divide by that 5 at the end. 40 divided by 5 is 8. 7 over 5 does not reduce, so we slide that 5 right there, 5x plus 7. And they seem 5x plus 7x plus, it's written backwards, but it looks like the correct answer is D. 7 is a real quick factoring. You see you have two perfect squares with a negative sign in between them. So this one should go pretty quickly for that a plus b, a minus b pattern. So 9x squared minus 25. So the square root of 9 is 3, so we have 3x and 3x. The square root of 25 is 5, so we have 5 and 5. 1 is positive, 1 is negative, and so it appears as if C is our best choice. All right, number 8 does have different instructions. So notice on question 8, it's not only asking you to factor, it's also asking you to solve. So yes, there's a way to go about that and do it backwards if you'd like. That lesson is in section 11.3, I believe. 11.3, perhaps 11.2. We're given the answers. You're looking for the quadratic. I would probably just factor it. So this is number 8. So 2x squared plus 9x minus 35. So we need to slip and slide that. Again, it is equal to 0. We are solving this. So x squared plus 9x minus 70. So factors of 70 that add up to 9. How about 14 and 5? One needs to be a positive, one needs to be a negative. If I multiply by that 2 in this first step, I need to go back and divide. So I end up with x plus 7 and 2x minus 5. And when I set each of those factors equal to 0 and solve, this one gives me negative 7. And this will give me positive 5 halves, making the correct answer C. Number 9, it looks like they did it by the square root method. You have some options. Here, would it factor? I don't know. I probably wouldn't do question 9 by factoring. I would probably just do square roots. So 6x squared equals 90. This goes back to a lesson from chapter 10. No, that's a lie. Chapter 11, section 11.1, the square root method. You want to get that squared term by itself. So let's go ahead and let's divide by 6. So we get x squared equals 15. And now we're free to take the square root of each side. So we have plus or minus radical 15, which makes, now they wrote it out on the answer choices, but the answer is B. Number 10, you see that I value in the back. Question 10 is from section 10.8 in the book with imaginary numbers and complex numbers in that lesson. So we have 5 minus 2i and a negative 1 plus 3i. And we're just going to simply FOIL. So 5 times negative 1 is negative 5. 5 times 3i is 15i. A negative times a negative is a positive 2i. And a negative times a positive is a negative 6i squared. However, remember that I squared is equal to negative 1, so that's going to change this sign because that negative 6 times that negative 1 will change this to a positive 6. And so I have like terms here, 1, and I have like terms here, plus 17i, which makes the answer D. Number 11 is back to using that square root method. At first, yeah, we're also going to have some imaginary numbers in there. This one does factor a little bit easy. Well, no, it's not going to factor great, so I would use the square root method because that's a positive 16. So let's get this x squared isolated. Let's jump that 16 to the other side. Let's divide both sides by 4. And now we're going to take the square root. When I take that square root, I'm going to pull out the radical with a negative 1. That's what I is. And then I have the square root of just positive 4. So this becomes I. This, of course, is plus or minus 2, which makes the answer 2i or negative 2i, which would make the answer B. Number 12. 12 looks like it would be kind of tricky. I think those hundreds at first glance are going to drop out. Let's see what happens. X squared plus 20x plus 100 equals 100. Did I get that right? Yeah, so these are going to drop out. So in order to solve whether you're going to factor or whether or not you're going to use quadratic formula or complete this square, which I wouldn't do that unless I had to, you need to have this set equal to 0. And right there, those hundreds are just going to drop out. So if you were going to use quadratic formula here, your C value would just be 0. But I would just pull out that GCF. You have an x in this term, you have an x in this term. I would pull that x out front, and I would just factor that up. That's going to be the quickest method. So this is going to give you x equals 0, and this is going to give you a negative 20, which makes the answer A. 13, here's a square root. This one's from chapter 10. 10.6 to be exact. Is it scary how much the math teacher knows exactly what goes in what section? This is from 10.6. The square root of x plus 3 plus 5 equals 10. Same idea as the squared. You want to get this piece by itself, so this positive 5 needs to jump over that equal sign. So let's go minus 5 minus 5. And then we're going to think to ourselves, how can I undo that radical? What is going to be the thing that is the inverse of that square root? And of course that means to square both sides, which is just going to free that and kill off that radical completely. So it's x plus 3. 5 times 5 is 25. Take that 3 to the other side. And we have x is 22. And so the answer is C. 14 is super similar. Don't let that fractional exponent scare you off. It is kind of a weird font. It is intended to be an exponent. I have no control over how that's printed on question 14. Also from section 10.6. And you can tell that that exponent piece is already isolated. So this is a real quick problem to solve. How do we undo taking something to the 1/3 power? This is the same thing as cube root. So I'm simply gonna cube both sides. And if you recall, taking a power to a power, you would multiply there. And so 1/3 times 3 is just 1. And so that's just gonna make that go away, and we have x minus 7. On this side, don't forget it's 4 cubed, not 4 times 3. So 4 times 4 times 4 is 64. Add the 7. And x equals 71. And so our answer is A. 15, solve the quadratic equation by any method. All right, so now you're free to do whatever you'd like. We did, between the factoring and chapter 11, there's a lot of these on the final because they simply were a lot of them throughout the course. And as I mentioned on the first day of school, solving these is kind of our our main task throughout the semester. So I gave you a variety of types here to solve. So plus 16x plus 61. There are no factors of 61 that add up to 16. So factoring is out. We have to use quadratic formula. If you look at the 4 answer choices, you can tell that they used quadratic formula. You probably don't, based on just looking at those 4 answer choices, if you're looking at them now, you can pick out the correct answer without actually going through and doing the whole quadratic formula. So our quadratic formula starts with negative b. Since this is a positive 16, we're going to get negative 16 plus or minus the square root of b squared minus 4 times a times c all over 2a. And so this is negative 16 plus or minus the square root of 256 minus 4 times 61 is 244 over 2. And so negative 16 plus or minus the square root of, what is that, 12? But that is not matching any of the answer options. Sorry, let me put my glasses on real quick here. So b squared 256 minus 4 times a times c. 4 times 6 is 240, 244. I didn't subtract incorrectly. Plus or minus 12 over 2. Oh, I understand. No. Oh, I do understand where this is heading. All right, so we got to keep going with this one. Don't stop working. I take back what I said because this is going to be simplified. I was looking at the options there thinking it had to be D, but that is not the way that is. All right, so let's break that 12 down. 12 is 2 and 6. 6 is 2 and 3. We have a pair of 2's. One guy cancels. Remember, whatever circled comes out of that radical. So we have negative 16 plus or minus 2 radical 3 over 2. Both terms in the numerator have a common factor of 2. So we're going to pull out that GCF, and it's going to be negative 8 plus or minus radical 3 over 2 with that 2 pulled out in front. And now those two finally cancel. And so now, thank you for your patience, the correct answer is B. Sorry, I might have misled you there at the beginning. Just filling the silence, so to speak, and babbling, and that one got me in trouble a little bit. All right, 16. We have negative 2x squared plus 7x plus 9. Looks like this guy is going to factor. I don't love that it starts with a negative, so if you're going to choose factoring, I would multiply everybody through by -1, and then you could probably factor with that slip and slide method. I think just to practice, I'll go through and I'll do it with quadratic formula. So negative b plus or minus the square root of b squared minus 4 times a, notice a is negative, times c, all over 2a. And so we have negative 7 plus or minus the square root of 49 plus negative 4 times negative 2 is a positive 8. 8 times 9 is 72, all over negative 4. So we have negative 7 plus or minus the square root of 121, all over negative 4. This is a perfect square. So 11 times 11 is 121. I'm going to take my work kind of up here. So negative 7 plus or minus 11 over negative 4. And now I'm going to split that. So negative 7 plus 11 over negative 4. And negative 7 minus 11 over negative 4. So negative 7 plus 11 is a positive 4. Divided by negative 4 is negative 1. Negative 11, take away 11 more is negative 18. Negative 18 over negative 4 is going to reduce down to 9 halves. So my two answers are 9 halves and negative 1, which makes the answer 9 halves and negative 1, B. B is the winner. All right, I think I'll just finish the page here. And so we'll do 17 and 18, and then that'll do it for part 1. Oh, and that works out to be exactly half of 36. So that is perfect. 17, 5x squared minus 5x plus 2 equals 0. So again, I would use quadratic formula. So negative b plus or minus the square root of negative b squared minus 4 times a times c, all over 2a. Another argument to be made for the final, having so many of these kind of quadratic formulas, is you just practice that, so it should be fresh in your mind, so that should be a good thing. So 5 plus or minus the square root of 25 minus 5 times 4 is 20 times 2 is 40, so minus 40 all over 10. And so we have 5 plus or minus negative 15 will be underneath that radical over 10. And so what's going to happen now is that it's actually going to split. Please remember that all of your complex numbers, if they involve an I, you have to split that. And so we're going to have 5 over 10 plus or minus the square root of 15. Pull that negative out, so the I is going to go right there, over 10. 5 over 10 can reduce. My guess is when I look at the answers, they're going to have written this twice. So just kind of, oh no, they didn't. They used a plus or minus option. All right, and they put the I right here, which is super funny because if you look at 10 textbooks, some of them, this is the way I always wrote it, with the I in front of that radical so that it doesn't get lost in the back. Mathematically accurate would have that I in the back, but just go with it. So this is the answer we're going to pick, which means the correct answer is B. All right. Number 18. Notice that, again, it's a cube root, so we're going to have pairs of 3 or groups of 3. The 3 in that cube root is awkwardly large font, so you just kind of have to deal with that. 18, so we have the cube root, 48, a to the 16th, b to the 12th. I'm going to break that 48 down any way you want to is fine. So 2 and 24, 2 and 12, 2 and 6, 2 and 3. You have 4 2's. You only need to circle 3 of them. It doesn't matter which 3 you pick. And 2 of those cancel. So that 2 breaks out of the radical. This guy and that guy do not have anybody to kind of buddy up with. So they're stuck underneath the radical. Remember that that is a multiply. So far I know that I have 2 out. And I'm going to have a 6 underneath. Now I'm going to take these exponents and I'm going to divide them by 3. So 3 divides into 16 5 times evenly, so it's a to the 5th on the outside. But we have 1a remaining, and so we have a to the 1st on the inside. When we do 3 divided by 12, we all know that goes in evenly 4 times, and so we have 4 groups. Perfectly with no remainder, so we have b to the 4th. Final answer here, and so, ooh, tricky that they put that none of the above. It's just a test generator, so I don't have a lot of control on that. So it looks to me like our correct answer is A. All right, that wraps up our first half. Stay tuned for part 2. Hope y'all are doing well. Good luck.